So first of all, if we discuss about total internal reflection, so what actually total internal reflection is and how it is possible for any transparent surface to reflect complete light when passing through it. So there are two conditions for it. First of all, let's consider the same example of that dense and rare medium. Then we discuss about the reflection in that surface. If we have a medium, glass medium or a dense medium, and we say that the first condition for this, light must travel from dense to rare medium. This is the first condition of total internal reflection, that light must travel from dense to rare. And if we describe what total internal reflection is, so for total internal reflection, we can write reflection of light waves when passing from transparent sub transparent medium. So normally in transparent medium, we already discussed that light can bend away from normal or towards normal in two other conditions. But when light passes from dense to rare, so light bends away from the normal. So in total internal reflection, if we consider the same example of that transparent object, so there is a normal between this surface. So in normal condition, if light passes from dense to rare, to it bends away from the normal. But if we increase the angle of incidence, like in previous example, we consider only one angle of incidence or any random angle of incidence for that. But if we increase the angle of incidence, let's suppose if we increase angle of incidence, since light is bending away from the normal, so if we increase the angle of incidence, so it starts bending more away from the normal line, right?
Yes.
Okay, so at certain point when we increase angle, so it happens like this, that this is our incident ray, this is incident ray, So after increasing the angle and at certain point, light will bend at 90 degrees like this. When passing from dense to rare, it bends away from the normal and light will appear somewhere this point. So light completely bends at 90-degree angle with respect to normal. Okay, because in normal reflection light bends away from the normal, but if we continuously increase the angle, so at certain point depends upon the density of the glass or density of that medium, light bends at 90 degrees, right?
Yes.
Okay, so when light bends at 90-degree angle, so this angle of incidence, let's suppose if we draw normal line here and we find this angle of incidence, so we can say that when light bends at 90 degrees, so the angle of incidence will be equal to critical angle, right? So when light starts bending at 90 degree, so rather than saying that the incident angle, we can say that incident angle will become our critical angle, right? This is a certain fixed value for every medium. You don't need to remember each and every value for every object or any medium. This is our conceptual point which you just want to remember about it, that critical angle is such an angle at which light bends at 90 degrees, right?
Yes.
So this is our critical angle. It may be 40, it may be 60, it may be 30, depending upon the density and the depth of that medium or glass. So if we now further try to increase the angle of incidence, right? Which means that if we increase angle of incidence greater than the critical angle, if we try to increase angle of incidence greater than the critical angle, so at this point the light rays will starts to reflect or completely reflect through the glass medium or the dense medium, right? So if we increase the angle of incidence which is greater than the 90 degrees angle, so after passing through the medium light will completely reflect like this. So this is the incident ray, and if incidence ray is greater than the critical angle, so after passing through this light will completely reflect out from the surface again, right?
Yes.
Any confusion?
No.
Okay, so there are basically three situations here. If we kept incidence angle normal, so light will bend away from the normal, right? And if we increase angle of incidence, so at certain point light will refract or bends like this, that the normal angle and the refracted ray will be at 90 degrees, both are perpendicular to each other. And if we further try to increase the angle of incidence that is greater than the critical angle, so light will completely reflect from that surface rather than bending through that surface, right? So first condition for total internal reflection is that light must travel from dense to rare medium. Okay, because in this condition light bends away from the normal. And the second condition for total internal reflection is that the angle of incidence will be greater than the critical angle, greater than critical angle, right?
Yes.
So it means that there is no confusion in critical angle and total internal reflection, right?
Yeah.
Okay. And further, if we discuss about the refractive index, so what actually refractive index is? Have you studied about it?
Yeah.
Okay. So what is the formula for refractive index?
We haven't done the formula.
Okay. So basically refractive index is a quantity, or you can say that a fixed value for every medium, which shows you that how much it can refract or bend light after passing through it, right?
Yes.
It is a unitless quantity because there is no unit, so we can say that it is a unitless quantity, which tells you that how much light will be bent after passing through it, after passing through the medium. So if we discuss about the refractive index of air, water and glass, these are very common examples. So you need to remember the refractive index for these common mediums. So if we discuss about the refractive index of air, so what will be the refractive index of air? Does light bend or reflect in air medium? If light is passing in air medium, so
It does, right?
light travels straight in air medium, which means that air will not bend light very much. So there will be value of 1.009293 something. So we consider refractive index as, if we write the refractive index for the air medium, so we consider as 1.0 round off. And if we discuss about the water and glass, so what will be the refractive index for water? Have you studied about it? Refractive index of water and refractive index of glass.
No.
Okay, so the refractive index of water is 1.33. These are very famous and common mediums. So we need to remember about these values. And for glass, 1.5. So these are the refractive index of our commonly used mediums in our daily life. And if you want to explain or define refractive index in other ways, so in scientific way, we can write that refractive index is the ratio of refractive index is the ratio between sine angle of incidence and sine angle of reflection. Sine angle of, right? So the formula will be like this. Small n is used for refractive index. Small n is representing here refractive index of any material. Refractive index. And in formula, you can simply write sine incident over sine refraction, because we are discussing about the bending of light waves. So sine angle of incidence divided by sine angle of refraction. So then we can calculate easily the refractive index of any material, right? You can just simply pass the beam or a single ray of light from that medium, then measure both angle of incidence and angle of refraction of it, then divide sine of both values. You will get the refractive index for that specific medium, right?
Yes.
Any confusion?
No.
Okay. So this is the formula for calculating the refractive index. And further, if we discuss about it, so you can alternately you can use this equation 1 over sine c. C is used for the speed of light. This is another formula to calculate the refractive index from that medium, because if light goes straight, let's suppose there are 2 points, point A and point B, and if light ray passing straight from point A to B, so there will be some time taken by it to travel the distance of A to B. And if same distance to be covered from any dense material, if there is some dense material in between point A and B, so will light travel fast from A to B or will take greater time than the above equation or above situation? In first situation, light is going straight in air medium, and in second part, light is passing from point A to B, but there is a dense medium between point A to B. So in which situation light will reach fast at point B? In situation 1 or 2? Light will reach first at point B, at point B in situation और in experiment. किस experiment में light जल्दी reach करेगी? First experiment or second?
The first one?
The first one, because in second light is also moving with same speed, but there is a difference of direction, because in first situation light is going straight, so that will be the shortest distance. But when light passing from a dense medium, so due to the refraction or bending of light, light will take more time to reach at point B. So light will reach first at point B in situation number 1, because light is passing from rare medium, and in situation B light is passing from dense medium, so light will take little more time than the situation 1. So you can also calculate the refractive index of any medium with the help of speed of light. And if you want to write the speed of light, so the fixed value, or you can say the speed of light will be equals to 3 into 10 to the power 8 meter per second. So this is the speed of light at which the light travels through any medium. But due to the change in direction or due to the refraction, light will take more time to travel from one point to another, right?
Yeah.
So these are two formulas to calculate the refractive index, and you need to remember about these three medium because these are very common and very easy to calculate, and we use almost in every example. So this is for the refractive index, and we discuss about total internal reflection and critical angle. Let's try to solve some questions regarding it.